Please welcome Tom Marnick.
Hello, Aras community. It's a pleasure to be with you today. I'm Tom Marnick, and I'm going to be talking about Ansys Minerva, a simulation process and data management solution from Ansys. So many of you may be familiar with Ansys. We've been around for many years. We just celebrated our 50th anniversary. And as you can see, I'm sure most of you think of us as a simulation company, and we are a simulation company. We have spent the past 50 years building the best simulation tools, fastest, most accurate solvers that cover the broadest array of real-world physics compared to any other simulation company in the market today. And we've done that through a series of acquisitions, partnerships, as well as organic development of our proprietary simulation technology. So you might be wondering, why are we, building a platform to do simulation process and data management? And so I want to give you a little bit of background. Obviously, digital transformation is, taking over the industry. That's really the theme of the entire ACE conference, digital transformation. And we've noticed this in our customers as well. The other thing we've noticed is that customers tend to have different names for their digital transformation initiatives, different terminology that they use to describe what they're trying to accomplish, whether that's model-based systems engineering or model-based design, digital threads, digital twins. They all come down to doing more simulation. Because when you think about what engineering is really all about, the only thing left that happens in the physical world when it comes to engineering is physical testing and prototyping. So if you're truly going to digitally transform your product development and engineering activities, you need to do more simulation by definition. And companies like Lockheed Martin are recognizing that to the point that they are making simulation a mainstream activity in the product development process, which honestly has not been the case for many companies over the years. Simulation, even today, is done on portions of the product, not the entire product, and it's not done throughout the product development life cycle. It's often done in a very specific phase of verification and validation. So it's our belief that simulation has to be a mainstream activity in the product development process in order for digital transformation to truly become a reality. Now, the challenge with that is that unlike CAD data, simulation data has not been managed for the most part the way we've been managing CAD data with PLM systems for the past several decades. And when you combine that fact with the reality that simulation analysts are highly specialized, if you think about fluids and structural and electrical simulation, those are areas of physics that require a depth of knowledge and specialization among the analysts that ends up siloing their activities to a certain extent. And when you combine the fact that you have siloed activities with unmanaged data, and just to add to the complexity, a large number of simulation tools to address these various areas of specialization in the various physics, and I'm just going to organize my data however I want on my local hard drive or on shared drives. And the only way to organize things is by how I name my folders and what my folder structures are. And oh, these are really large files that we're creating, so I can't fit everything on the drive, so I have these USB drives that are maybe, in a filing cabinet or on in my desk drawers. So a bunch of critical data is not available. Then you think about the steps that I have to go through to actually execute a simulation. I've got to gather the data. I've got to make sure I have the right versions of the data. I need to clean up the geometry. I need to generate meshes. There's a whole series of pre-processing tasks, a whole series of tasks I do to set up my simulation problem, run my simulation problem, and maybe I'm going to run it on remote hardware somewhere. This all takes time and requires me to know how to move files around my network to get that done. So I've got unmanaged data, siloed activities, a complex process to execute simulation. That all makes it very difficult to mainstream the activity of simulation in the product development process. And this is what we're trying to solve with Ansys Minerva, provide a platform to manage the data and help mainstream these activities in the product development process. And the reason we want to do this, the reason we think this is so critical for digital transformation, is because engineering is about decision making. And I can't make decisions without information. Now, it's not just enough to give me a bunch of information and expect me to make a good decision. If you give me information, I need to know what the context of that information is. If you give me a solid model and ask me to perform simulation, I need to know things like, where does this model, where does this part, where does this component fit in the overall product? I need to know things like, what are the requirements of this product that I'm building? What conditions is it going to be subjected to in the real world, and how is it going to be expected to perform? And the only way I can get that context is if I have traceability. And traceability requires managing the data, right? If I don't have my simulation data under the same kind of configuration management control that I have the rest of the product definition data, I can't possibly have true and accurate traceability, which means I can't have context, which means I don't have good information, which means I might not make good decisions. Okay, so this is really the problem we're trying to solve with Ansys Minerva. Now, a typical customer environment, because PLM systems have been around for decades, for what happens in systems and design engineering, generally there are systems in place to help those engineers manage that data and manage those activities. So if you look on the left, there, this customer, the design engineers and the systems engineers have tools like IBM Rational tools and Jazz tools to manage requirements and software engineering data. This particular customer actually had two PLM systems because they had Creo, so they were using Windchill PPM Link, and also they had NX, so they were using Teamcenter to manage their CAD data. They had Cadence and Mentor, and then they even had proprietary databases for materials and test information. And then when you look at what the analysts do, these silos of specialization amongst all these different analysts using very many different tools, performing many different simulation activities, they didn't have a system to manage that data in. So we showed them how they could use Ansys Minerva, manage all the data, manage all the activities, make the activities easier to execute for these engineers, but maintain connectivity to the external systems. Now, we built Minerva intentionally on top of Aras Innovator because Aras Innovator by far has the most open and powerful, flexible, extensible platform to connect to these external systems. So we knew that we could not demand that our customers only use Ansys solvers, for example, to do their simulation. And we also knew that we couldn't demand that our customers replace their PLM systems and start managing all their data in Ansys Minerva. So we needed an open agnostic platform that we could connect everything with. So what is Ansys Minerva more specifically? So there's basically four major categories of capability in Ansys Minerva. The first is to manage the data, and it has to manage all types of data. So the open extensible data model of Innovator was critical for us. And the ability to manage any kind of model, the ability to manage any kind of simulation result. Managing the data isn't enough though, because simulation, like everything else, is a process. So we also want to give our customers the ability to manage the process of simulation, the tasks that need to be executed to accomplish a simulation, but also to break down the silos between the areas of specialization in simulation and facilitate multi-user workflows. So a structural analysis can lead to a fluids analysis, can lead to an electrical analysis, and a complex multi-physics workflow could be managed by Ansys Minerva. We also want to facilitate the actual execution of the simulation tools. Make it easier to run the simulation job, whether you're running it on your local workstation, a more, a beefier workstation down the hall, or an HPC high performance compute cluster halfway around the world. Take the burden off the user of knowing what operating system level commands they need to type in order to execute those jobs, and make this all just work for them through a web browser. And then, as I talked about earlier, the ability to connect to existing systems and third-party tools is absolutely critical. So, as I said at the beginning, we're known for our solvers at Ansys. We have the best, broadest, set of solver capabilities in the industry, and we're very proud of that. And that will always be our core competency and the thing that we really build the company on. But we also recognize that just delivering the best solvers isn't enough, that we also have to make the solvers easier for our customers to execute, easier for them to incorporate into the product development process. We need to give them a platform to use the solvers with. Now, our platform is pretty extensive. Not only can we manage the simulation process and the data, but we can also manage your materials information and make it very easy to ensure that the analyst is using the right material when they do that simulation. So all the physics are covered. We also have the ability to perform designs of experiments and provide automation around complex tool chaining and creating simulation optimizations to optimize designs. All of this delivered on a platform which at its core is Ansys Minerva for SPDM. And as everybody on this call with PLM experience is aware, these kinds of capabilities aren't adopted by just flipping a switch. It is a process of first managing the data, getting that under control. Next, managing the processes of simulation and facilitating those multi-user workflow activities. Enabling all the engineers in the organization to collaborate more effectively and get the value of simulation. To really enable the point where simulation is a mainstream activity in the product development process. And this is what really enables the entire enterprise to realize things like digital transformation, digital thread, digital twin. you cannot have a complete digital thread if the simulation information is not part of that thread. Okay. So very quickly, some more detail about the capabilities that I've been talking about with this product. 4 major categories of capability. The first one here is search and reuse, right? The reason that we manage data is because we want to be able to reuse it. We want to be able to find it quickly and easily in order to reuse it. So complex simulation output files, metadata extracted, visualization available, stored in the database, searchable, browsable, viewable inside my web browser. So I can look at simulation results without having to open up a very large, results file in the tool that created it. I can just look at those results from my web browser. Track the relationships between files, complete configuration management so I know that I'm working with the right version. And you're already familiar with the kinds of reporting capabilities that a system like this provides. So the ability to get reports and understand the information that Minerva is managing is critical. I talked about the collaborative workflows. So the ability to treat the simulation activity as a project with multiple tasks and multiple users and understand the dependencies between those tasks and those users. Monitor those activities in real time so that you can keep track of who is doing what and understand where you are in the process. Communication threads, the ability to have reviews and sign-offs and maintain a complete audit trail of that simulation activity is also critical. And then when we talk about leveraging the compute resources that exist in the network, it can actually be a fairly complicated process to run a simulation job on a remote cluster. And it's also true that a lot of analysts do not regularly run jobs on remote clusters, so they may only have to do it occasionally. And every time they do it, they have to go through a whole process of figuring out what commands they have to type, how to transfer the files around, and how to interact with the job scheduler. With Minerva, web form, you fill it out, select your input files, press go. Minerva takes care of doing all of the background work to actually execute the job and run it on the cluster. You can monitor it while it's running from anywhere. You don't have to stay at the machine where you submitted the job, and you can be notified when the results are ready and available for you. Another major capability is making simulation easier to run. So what we mean by democratization is allowing design engineers and non-simulation experts to have the ability to execute complex simulation tasks. So, for example, you set up a design of experiments with a complicated, process integration tool chain. We've used our OptiSlang design optimization tool, for example, to create a tool chain that is going to run, take input from an Excel spreadsheet, and then it's going to run an Ansys mechanical run, and then maybe it's going to run a MATLAB Simulink run. And it's all of these tasks are chained together and then automated to run over and over again to optimize a design. That can be presented to an engineer as an app in their web browser. They click on that app, enter the appropriate input information, the parameters that they want to optimize for example, and press go, and Minerva runs everything in the background and comes back with your results and your reports and your graphs and your output that the engineer can look at to make decisions. So it's about taking complex simulation activities, automating them, and then packaging those automations as an app that can be delivered to any engineer anywhere with the web browser, making simulation more accessible beyond the specialized community. Okay, now we're going to run a brief video that shows you what Ansys Minerva looks like running live. So as you see, a dashboard, so I can have the things that I care about displayed to me right on my home page. I can mouse over certain things to get more information. Here I'm looking at a simulation work order and drilling down into the specific tasks that are being run for this particular type of simulation. I'm going to go into more detail of an actual project that's been running. And you see, I can see my input files for my project. I get the metadata that you're used to in Innovator. I can look at the tasks that need to take place for this particular project, the roles, the people who are going to perform those tasks, what their names are, and then I can see the deliverables from this project. So this is a project that has already run, and I've got the complete audit trail or history of what's happened and who signed off on the various sign-off phases in this particular task. This is all, as you would expect, completely configurable. And when I'm looking at files in Minerva, I can click on the details of these files to see the viewables, the metadata, the traceability, the connections between the dependencies between files, right? So the CAD version, the cleaned up geometry that we created from those CAD versions, then the input, the mesh that was input into the simulation tools, and then the actual output of those simulation tools. All here very easily navigable in a nice graphical interface, and can hover over any item here to see more information, or click on something and then see more detail in my properties view. So this is really what Ansys Minerva is all about. It's about completing the digital thread by making sure that simulation can be woven into that digital thread. Okay, so it's all about everything, that we do for our customers is about positive business outcomes. And what customers care about, and they've cared about this forever, better, faster, cheaper is what everything boils down to. And simulation is critical for doing things better, faster, cheaper. And there's lots of data to support the fact that customers who do more simulation, customers who come closer to having simulation being a mainstream activity in their product development process, they have better business outcomes. They get their products to market faster, they get higher quality products to market, and they reduce their overall engineering costs so that they can provide those products to their customers in a very cost-effective manner. We have customers across all industries, and we're seeing significant benefits from those customers. So no matter what their industry, no matter what their particular digital transformation vision is, they found that Minerva has a role to play, and Minerva can have an impact on the level of effort that goes into engineering and the time, the overall cycle time of getting the product from concept to production is compressed when you do simulation more, and when you do simulation more effectively with Ansys Minerva. So our theme at Ansys has always been about pervasive simulation. We firmly believe that simulation is critical to successful product development. And with product complexity increasing as dramatically as it has been in the past several years, pervasive simulation is even more critical. And with Minerva, thanks to the underlying technology of Aras Innovator, combined with the Ansys extensive expertise in simulation, this combination is just completely unbeatable. And with Minerva, we can deploy the technology quickly, leverage our out-of-the-box capabilities and expertise around simulation. We can configure it quickly to fit any requirements for any customer, and we can connect it to everything, whatever system the customer has in place that we need to connect to, and whatever simulation tool that the customer has in place that they need to execute, we can make it work with Minerva. So that's my presentation. I have time for some questions. It looks like we have 4 minutes left, so I'll see if there are any questions I can answer. Okay, so I see a question here. How many companies are in production with Minerva? What is the largest deployment? So Minerva is relatively new to the marketplace. So most of our customers now are in, a pilot production phase for the most part. And right now our largest deployment is 5,000 customers. They are not in full-scale production yet, meaning not all 5,000 users are utilizing Minerva in production today. But we are ramping them up over the course of this year. Okay, I'm not seeing any other questions. So I really appreciate everybody's time and attention. Oh, one more question. How does Minerva differ from an MDAO solution like Phoenix integration? So actually, Minerva, our product, our Ansys OptiSlang product is more analogous to Phoenix integration. Okay, so Phoenix integration would be a tool that we would integrate into Minerva to do design optimization if a customer preferred that over our OptiSlang solution. Okay, so Minerva is going to manage the data that a tool like Phoenix integration would create and facilitate the execution, of the Phoenix integration process tool chains, which is exactly what we do with OptiSlang today. Another question here is, what about multiple vaults? Minerva supports multiple vaults. We can do the same things you can do with Aras Innovator, to have data replicated, to multiple vaults and cached around the world, right? So especially with large files like simulation files, we really want to make sure that we're optimizing the distribution of this data across the enterprise, and making sure that we design a deployment to minimize the need to transfer big files around the network as much as possible. Okay, let's see if we have any more questions. I think this is it. Is it possible to install Minerva on Linux as well? So that's a great question, because we do have a lot of customers in the simulation world who are pretty much dedicated to Linux. HPC clusters tend to be predominantly Linux. So most of our customers work in a mixed environment where Minerva is installed on Windows machines, but the solvers may be run on Linux. We are actually working with Aras right now, and it's going to come out later this year, a version of the Minerva Vault, will also run on Linux before the end of the year. And with that, I think we're out of time. So I am going to thank everybody for their time and attention, and I look forward to hopefully talking about how you can use Minerva in your company and help your digital transformation journey by making simulation a more mainstream activity in product development. So thank you all.